Primitive data types. There are 8 primitive data types in Java. 4 of them represent integers, the byte, short, int, long. 2 of them represent floating point numbers, float, double. 1 of them represents characters, char, and 1 of them represents Boolean values, which is the Boolean. If you're not familiar with a Boolean, it has 2 states. In Java, it's true or false. It can only be either one of those values, true or false. There is 6 numeric primitive data types. The difference between the numeric types is their size and the values they can store. So we have 4 for integers, which is the byte, short, int, long. We have 2 for floating point numbers, which is the float and the double. You're going to need to know the size of each. So byte is 8, the short is 16, the int is 32, long 64, float 32, and double is 64. You don't need to know the min and max values. I'm not going to test you on that. But the thing that you should know is how many values that it can hold. So you should be able to calculate those values, right? For a byte, you should know that it can hold 2 to the 8th possible values. For a short, 2 to the 16 possible values. For an int, 2 to the 32 possible values, and so on. Characters. A character variable stores a single character. Character literals are delimited by single quotes. Example declarations is char, top grade, and then they use the single quote A. Char terminator, they use a single quote in the semicolon. Separator, they use they put in a space right here. Okay. Note the difference between the primitive character variable, which holds 1 character, and the string object, which holds multiple characters. Also make a mental note that the string uses double quotes, while the char uses the single quotes. Character sets. A character set is an ordered list of characters with each character corresponding to a unique number. A char variable in Java can store any character from the Unicode character set. The Unicode character set uses 16 bits per character, allowing for 65,000 unique characters. It is an international character set containing symbols and characters from many different languages. The Ascii character set is older and smaller than the Unicode character set, but is still quite popular. The Ascii characters are a subset of the Unicode character set, including the uppercase, lowercase, punctuation digits, special symbols, and control characters. In the back of the book, there's a section on the Ascii and Unicode character sets. You can also find the Ascii and Unicode character set online. They're going to have the number entries for each one of these characters. A Boolean value represents true or false condition. The reserved word true and false are the only valid values for the Boolean type. So here is an example of a declaration. They specify the data type, the variable, and then they assign it the false value. A Boolean variable can also be used to represent any 2 states, such as a light bulb being on or off. So what they mean is you can create a Boolean variable to represent the state of a light bulb, and you can store whether that light bulb is on or off. So the on state would be true and the off state would be false. So I created this program called Primitive Data Types. The name of the class matches the name of the file. I created my main method header. Inside my main method, I'm going to put my programming statements. Before I begin, I'm going to compile to verify I have not made any mistakes. It does compile. So in this program, I'm going to talk about these 8 primitive data types and their literal values. So the lecture did not actually mention anything about the literal values, so I'm going to go ahead and show you that within this program. So the first example is the byte. I'm going to go ahead and create a byte. So if you noticed, I created my byte variable, but I did not assign it a value. And then I came over here and I tried to print it out. So let's see what happens when we try to compile this program. So right away, Java noticed that the variable might not have been initialized. That's because we never actually assigned it a value. Now, sometimes Java will not actually recognize this. When you have multiple files, it's not going to notice that you didn't initialize this value when you're trying to call it from a different file. But in this case, it's all in one file, and Java was able to recognize this as an error. So I'm going to go ahead and assign this a value. If you remember, a byte is 8 bits, so it has a possibility of 2 to the 8th power permutations. So that means it can be negative 128, positive 127. So I'm going to go ahead and make this 127. I'm going to take it to the upper limit. I'm going to go ahead and save and compile and run this program. And you can see my age is 127. Now, before we move on to the next example, what do you think is going to happen if I were to make this a 128? Let's find out. Okay. So what happened was Java noticed that this value was 128, and that's outside of the range of a byte. So it's not allowing me to place this value inside of a byte. So the literal value for a byte is any value within its range. So once I go over 127, then Java got upset. The minimum value I can have for a byte is negative 128. Let's see what happens when I make it 128. Java was perfectly okay with that value. So I can compile and run, and you can see I get negative 128. But what happens when we go down to negative 129? I reached my limit once again. So the next example is going to be the short. So I created a short variable and I set it to 32,000. This is like the attendance of a concert, and I printed out the variable right here. I'm gonna go ahead and compile and run, and you can see there is my attendance. Now a short is 16 bits, so that means there's a possible values of 2 to the 16 power, but it's also negative and positive, and I believe the high value for this is like 32,000 something. So if I were to change this to 33, I should run into the same problem that I ran into with the byte when I try to go out of the range. So I'm gonna compile, and you can see that I get the same error where Java sees this as an integer trying to go into a short. So it's basically telling me that this is too big of a number to fit inside this short. But once I change it to be within range of the short, then Java is okay with it. So for literal values for a short, all they have to do is just be within the range. The next example I'm going to do is the int. So I created an integer and I assigned it 6 million, and I'm printing out this value right here in this print statement. So I'm going to go ahead and compile and run, and there is my integer. Now it's going to follow the same rules as the other two. So an integer is 2 to the 32. It's a pretty big number. I always forget how big the number is, but I know if I keep adding zeros to this, at some point Java is going to be unhappy with it. So I'm going to go ahead and add another 0 to this value here. So now I have a integer value that might be bigger than 2 to the 32 power, but we'll find out. I'm going to compile, and it was okay with this. I'm going to go ahead and add one more 0, compile, okay, add another 0, compile. Okay, so now Java's finally upset at me. It's upset because it's saying that this value is too large to fit into this integer value, which has the possible combinations of 2 to the 32 power. So I'm going to go ahead and just remove one of these zeros, and I'm going to go ahead and recompile and fix the problem. Next example is an example of long. Okay, so I created a long and I assigned it a value that is bigger than what I assigned the B population. It's called world population. Put a few more zeros at the end. Now a long is 2 to the 64, so it should be able to hold this value. But let's see what happens when I compile. Okay, so I got an error compiling. So this is what the problem is. Okay, so even though long is big enough to hold this huge number right here, Java is still treating this as an integer literal. An integer literal is 2 to the 32. So this is too big to be integer literal. So we need to tell Java, don't treat this as an integer literal, treat it as a long literal. And the way that we do that is by putting a lowercase or a uppercase L at the end of this. I prefer an uppercase L because it's easier to read. A lowercase L looks too much like a 1. The accepted programming practice for this is always to use an uppercase L when specifying a long literal. So let's see what happens when I add this L at the end of this number here. So it did compile and it does run. So we had to tell Java, don't treat this value as an integer, treat it as a long. So then Java's saying, okay, well, this value is a long, so it can fit into 2 to the 64 power size, and I'm going to go ahead and assign it to the long, which also is 2 to the 64 power. Next example, the float. So I created a float, and if you remember what a float is, it's a floating point value number. So we have two types of variables that can hold float. We have the float and a double. So anything with a decimal point is considered to be a floating point number. Now, depending on how much resolution you want on the end of this, that's where you have to determine if you want a float or a double. A float is 2 to the 32, a double is 2 to the 64. But let's see what happens when we compile. Okay, so once again, we run into some type of problem here. Java's telling me that there's a possible loss of precision. It's found a double, but I'm trying to put it into a float. So this is kind of the same but reverse problem with the long, where Java sees this as a double literal. So it's making that 2 to the 64 bit. So it's too big to fit into 2 to the 32 inside of a float variable. So we need to tell Java to treat it as a float literal. So in order to do that, we need to either put a lowercase f or an uppercase f at the end of this value. So I'm going to go ahead and put an uppercase f and compile and run, and now you can see that Java is happy with this floating point value. I'm going to go ahead and make a code comment here. The next example is the double, and this one's pretty straightforward. So I created this double and I put it into this variable called fraction. I'm just going to print out to the screen. This is pretty straightforward. It compiles, it runs, and you can see it put it into scientific notation, but that's still the value of the double. If I come over here and I put a 1 in front and I compile and run, it went ahead and took it out of scientific notation. So when you have a bunch of zeros in front, it's going to move it to scientific notation. Now there are ways to format your value so you don't actually get scientific notation, but we'll talk more about that later. One thing to note is doubles can only have 15 significant significant digits. So once you have more than 15 significant digits, you will not be able to store those values into that double. If you have fractions that are that big, Java does have other classes that you can use to handle those, but they'll be objects and not primitive data. So the next example is Boolean. So this is kind of an interesting one. We're going to talk more about this one when we get to chapters 5 and 6, but I'm going to go ahead and introduce it to you now because it's important to understand all 8 primitive data types. So the way you do this is specify Boolean in the front of the variable and then give it some value. And I'm going to assign it false. So I created this Boolean value called state, and I'm using it to represent the state of a light bulb. And I'm just asking the question, is the light on? I'm gonna go ahead and compile and run, and I'm getting false. I can change this to true and see different results. Compile, run, and I'm getting true. Boolean values can only hold a true or false and nothing else. The next example is the char. So I created a char, and you can see that I only use one single quote to represent a char, and then I put in that character, and I'm outputting that value right here, and there is my output. Now char can be any character, so you can actually come in here and just put a space, and then, well, you can't see that, but there's a space right there. Now chars can actually be represented with the number in the Unicode character set. You're gonna have to cast those values to that number. I'm gonna do a quick example of that just to show you guys how that works, and you can see the different characters within the Unicode character set. Now, I'm not gonna go through all 65,000 possible values because you have to have those character sets loaded onto your computer in order to see that output. So I created this class called Unicode character set. The name of the file is called Unicode char set. My name of the class is Unicode char set. I have my method header. I'm gonna put my statements in here. I'm gonna loop through. I'm gonna use a for loop to kind of go through all the values of the Unicode character set. Well, not all of them, but just a portion of them. And then we can kind of see the values that come out of this. Now, I am going to use a for loop. We're not going to cover for loops until chapter 6. So please do not use for loops until we get to that point. So let's begin. So I made a really simple program that just uses a for loop and iterates 1,000 times and takes a number, an integer, and casts it to a char. And then we print out those values. I'm using the printf, so I'm putting out the index or whatever the current iteration is. And then I'm printing out the character. I'm allowing some extra space here so it looks nice and formatted. And then I'm checking to see if the current iteration is divisible by 9. If it's divisible by 9, then I'm going to go ahead and put a new line character so it looks more like a table and not just a whole bunch of messy output. We're going to talk about all this in chapters 5 and 6, the if statements in 5. The for loop is in chapter 6, so please don't be intimidated. I'm just doing this currently so that you can see the characters being outputted. Past a certain number, you will see question marks, which means that I do not have that character set loaded onto this computer because those are foreign characters. So let me go ahead and just compile this and run, and here is my output. You can see, well, some of these are new line. One of the characters might have been new line. That's why like the 11 and the 12, and I don't even know where 13's at. 13 might have been the return carriage. I have no idea. I have to look at all this. I don't have all this memorized. It looks like these characters did not print out correctly in this console, and you can see we have the percent sign, the %, and there's all these different characters down here. There's like the division, like the traditional division sign, and then it starts getting to a bunch of question marks. I think probably the best thing to do at this point is to run this in command prompt. So I'm going to go to open containing folder, cmd, and I'm going to do Java and the name of this class. Okay, so here is my output. Over here in this So over here in this console output, there were some characters up top that seemed like it didn't recognize, but in my actual console, my command prompt, you can see that it did recognize some of these, the arrow, up arrow, there's all these weird characters that it did recognize. Now there's question marks, it didn't recognize those characters, so it didn't print anything out. But there was one there that I recognized, one there, and one there.